8B, hypothesis testing for proportions. So we've looked at like just the general hypothesis testing procedure, like what are we actually doing? Last lesson we talked about how to write the null and alternative hypotheses. So now we're actually going to perform a hypothesis test. So remember our Coach Rivers free throws example. All right, Coach Rivers claimed to be an 80% free throw shooter, but he only made 32 out of 50 in our experiment. So P hat, that means the proportion from our sample was 32 out of 50 or 0.64. Okay, and then remember, this is the question we're asking. If P, which is the actual population, is 0.0 or 0.8. So if Coach Rivers is actually an 80% free throw shooter, all right, for him to shoot 64%, would that be normal? Would it be unlikely? Would it be really unlikely? All right, how do we know for sure? And so what we're going to do is to test how unlikely this result is, we're going to do something called a z-test. All right, to do a z-test, you need to know two things. P-value, all right? The p-value is the probability of obtaining a sample statistic that is as extreme or more. So in our case, we were talking about Coach Rivers being only shooting 64%. Okay, so the p-value would be the probability, all right, of an 80% shooter shooting 64% or lower. Okay, so we know if someone is an 80% shooter, they're not always going to shoot exactly 80%. They might shoot a little bit higher some days, they might shoot a little bit lower some days. The 80% is an average. Okay, so we're asking, the p-value is the probability that an 80% shooter shoots 64% or lower. All right, and then our level of significance, this little thing right here is the Greek letter alpha. Okay. Alpha is the probability of the study rejecting the null hypothesis. So we're going to think about this as like a cutoff value. So here's some common alphas. So 0.01, 0.05. So I'm saying if the probability of something happening is lower than 0.05, I'm going to say that's too unusual. Okay. Or 0.01 or whatever the alpha is. If our p-value, the probability of this happening, is lower than whatever the study sets as the alpha level, we reject the null hypothesis. Okay, in this case, we would say Coach Rivers is not really an 80% shooter because it's too unlikely that he shoots 64% or lower. Okay, so here are the steps. First thing we got to do is verify that we can use a z-test. All right, and so N would be our sample size, and then P in this case is the proportion from our hypotheses. Okay, so that we understand, if you see P like this, all right, that is population. Okay, if you see P like this, that's from the sample. So remember when we did the free throw activity and we said that the population was all of Coach Rivers' free throws, and we said that he shoots 80%, and then our sample was the 50 free throws he took, and that was 64%. Okay, so P by itself is the population proportion. P hat is the sample proportion. Okay, so when I go to do this math, I would be checking that the population proportion times the sample size is greater than 5. And then Q is still going to be 1 minus P, just like we've been doing since 2 units ago. Okay, so here are the steps. We're going to find the p-value with a graphing calculator. All right, and here are the calculator steps. As much as I love Desmos, it just doesn't have this set up to do statistical testing. So we're going to use your Casio. If you have a TI, I can show you how to do it on there as well. It's very similar. The buttons are just a little bit different, but the process is still the same. Okay, so let's do a z-test for Coach Rivers. He claims to be an 80% free throw shooter. He made 32 out of 50 shots. Is there enough evidence to support the claim that Coach Rivers is less than an 80% free throw shooter at alpha equals 0.05? Okay, so first let's verify that we can use a z-test. So N, he took 50 shots. So 50 times P, his population proportion was 0.8. So 50 times 0.8 is 40. And then Q would be 1 minus 0.8, so 0.2, and 50 times 0.2 is 10. Both of those numbers are greater than 5, so we can use a z-test. Okay, identify the null and alternative hypothesis. All right, well, our null hypothesis, so Coach Rivers claims he's an 80% free throw shooter. We think that he is less than an 80% free throw shooter. So our null hypothesis is going to be that P is greater than or equal to 0.8, right? That Coach Rivers is an 80% free throw shooter. And our alternative hypothesis is our claim that he is less than an 80% free throw shooter. All right, identify alpha. It's given to you in the problem of 0.05. And now we're going to find the p-value using the graphing calculator. So in the calculator, okay, we're going to press menu and go to stat. All right, in stat, we want test, so that's F3. We're doing a z-test, F1. And we are doing a one proportion z-test, so that's F3. Okay, in here, the first line, we need to put our alternative hypothesis. So our alternative hypothesis was that it was less than, all right. This P0 is our proportion, the number that's in our hypotheses, which is 0.8. Okay, X is the number of free throws that Coach made. So he made 32, and N is our sample size of 50. Okay, and so the calculator gives me a z-score, it gives me a p-value, all right, and it calculates for us p-hat, which we already knew was 0.64. Okay, so our p-value, remember this e to the negative 3 is scientific notation. So what I would do, the shortcut is, that means like move the decimal 3 places. The shortcut is add 1 less than this number, zeros. Okay, so my p-value is going to be this is 3, so I'm going to put 2 zeros in front, 0.002. I will just do 3 decimal places. Okay, so my p-value is 0.002. All right, I'm going to compare that to my alpha of 0.05. All right, so this is alpha. 0.002 is less than 0.05. So I am going to reject the null hypothesis. All right, last thing is we need a conclusion sentence, okay? So this is kind of a fill-in that you can use. So we are going to reject the null hypothesis because the p-value is less than alpha. All right, now this part, there is or is not enough evidence to support the claim. We have to go back to what the question asks. Our claim is that Coach Rivers is less than an 80% free throw shooter. So I'm going to put that here. Okay, our claim is that Coach Rivers is a less than 80% shooter. Okay, now we are rejecting the null hypothesis. Our null hypothesis was that he was greater than or equal to 80%. Okay, so if we are rejecting the null, it means we have enough evidence for the alternative that he is less than 0.80. That was our claim, so there is enough evidence to support the claim. All right, I put these colors up here because if you're writing the word reject, then P has to be less than. If we're writing fail to reject, P has to be greater than. So the blue matches and the green matches. Okay, and then here is or is not depends on where the claim is. Sometimes the claim is in the null hypothesis and sometimes the claim is in the alternative hypothesis. It just depends on how the question is written.